Guys, welcome to ILR Performance. This is the first of our dyno series. We're going to go through the dynamometer that we use here, going to do some setup, and we're going to do a number of videos after this, going through several different motors that we have here in the shop right now that are getting ready to go out the door after different kinds of work. So one of the things that we do here at ILR Performance is rebuild a lot of motors for ATVs, watercraft, snowmobile, and those motors don't get installed here. They get shipped back to the owner. Most of those owners are either out of state or out of the country. That's good because our reputation is that broad that we get that kind of work. However, anybody who's ever had a motor rebuilt or bought a crate motor knows that getting it in and getting it running and fired up the very first time can sometimes be a challenge. So one of the things that we do here at ILR Performance is any motor that gets ready to ship that we don't install, we put it on our dynamometer. We do break-in runs on brand new motors. If it's a used motor that we happen to be reselling, we'll dyno it, make sure everything's up to speed, do the usual leak down tests and compression tests and things like that. And we do that here on the dyno. So what we're going to do today is we're going to take a look at our dyno. We're going to take a look at how we set the dyno up originally, some of the thought processes that went into it. And we're actually going to put a motor onto the dyno. The motor will actually be run on the next video. It'll get too long if we try and do it all at once. However, show you how we do our setup and how our mounting attachments work, kind of give you an idea how this thing works. So this dynamometer started out life as a land and sea snowmobile dynamometer. This is a really incredible system that they produce. It's so simple to use on a snowmobile because if you've ever worked on a snowmobile or you own a snowmobile, you know that it's propelled by a CVT drive system that uses a rubber belt and a couple of variable pulleys. This particular system is set up so that you just literally unbolt the pulleys off the side of the snowmobile. You bolt the dynamometer on in place of those pulleys. You pull the pull starter or hit the starter button if you happen to have an electric start. You fire that snowmobile up and you actually make the run while it's in the snowmobile. It's really, really cool setup. We do some in-chassis dyno work on snowmobiles. We also do more and more on ATVs. That's quite a bit different setup than we have here. This is our engine dyno, and we're only going to dyno engines on our stand right now. But later on, if there's some interest, we'll show you how we actually put them on a ATV, a fully assembled ATV, and actually do a crankshaft horsepower dynamometer test. Not a rear wheel chassis dyno test. We actually do as much as we can directly off the crankshaft. Okay, so we're going to do a little walk around on the dyno here. I'll try not to be too shaky. This is our land and sea dynamite dynamometer. It is a water brake. The way a water brake works is water comes in from the bottom under pressure. It goes through a pressure regulator to maintain a constant pressure throughout the dyno run. That moves up to an automated load cell, and it's really just a flow controller that moves the water down out of that and into the brake. So horsepower is not actually measured. Horsepower is calculated by measuring the torque through the brake. And you'll see that this particular dynamometer has a tachometer output there. And since we're running directly off the crankshaft, we get a 1-to-1 ratio between crank RPM and dyno RPM. And by measuring the torque that's being generated at a given RPM, that gives us the horsepower output. Pretty simple mathematical formula that you can get almost anywhere. So what we've done on this dyno is we've taken and we've mounted a bearing plate back here. We've also mounted another bearing plate back here. Both of these are self-centering bearings, so if it gets slightly out of alignment, it doesn't make any difference. The dynamometer brake itself, the internal part of the brake, is mounted to the shaft. So as the shaft rotates, you can see that it turns the inner rotor, and inside that is the load, is the fan that generates the load. On the end of that, we have a coupler. Now this is very similar to what's called a Lovejoy coupler. However, you can see that in this particular case, where a Lovejoy coupler just has flat little tabs that are very similar to this, hopefully you can see that, this particular coupler actually encases the rubber damper. That gives us a much bigger rubber damper, so it can handle a load without destroying that. It also captures the rubber so that as it gets under any kind of load or any kind of vibration, that it captures this very solidly and provides power transmission. That particular coupler, anybody who knows anything about jet skis will recognize that as a Kawasaki jet ski drive coupler. Now that drive coupler is used for very, very high horsepower multi-cylinder watercraft. Watercraft use a similar arrangement where there's an engine with a coupler, and you'll see we'll use the opposite side of this coupler on our motor when we put it on here, out through a solid drive shaft, and it drives an impeller inside the pump constantly under a load. So this is a very good arrangement. It simulates the way that a watercraft would work under a load. You can see that we've used a much bigger shaft than would normally be in a watercraft, but it's very important that we don't have any spring in our dynamometer or it'll give us false readings. Originally, when I built this dyno, I thought, well, I'm going to use mostly single-cylinder two-strokes or two-cylinder two-stroke motors that have kickstarters on them. So I'll just kickstart them and they'll fire right up. Well, that didn't really work out all that well. So very quickly, I ended up needing to put an electric starter on. So I built this adapter. This is a high output 750 jet ski starter. I built this starter ring, and the jet ski starter, when it triggers, the gear comes out. Let me see if I can get this a little bit better. The gear comes out. It engages with our ring gear, rotates it, and fires the motor up. You'll see that in action when we get a little bit farther along in the next video and we actually run a motor. So coming from there, we have some electronics here on the dynamometer. Like we talked about earlier, we have the tachometer pickup. This is the load cell. And you can see that this wire runs up to an electronic piece right there. That piece, when this arm flexes, actually generates an electronic signal that the computer takes a look at and recognizes as a certain amount of torque. It calculates the torque. Obviously, we need fuel. So we have a fuel line with a fuel filter. We can split that into multis if we need to. That comes down to a fuel shutoff because we want to be able to shut that off. That comes down underneath. Let's see if we can get a little light on the subject. Okay, that comes down through aluminum fuel tubing, goes underneath, routes across to a fuel pressure regulator. It's really important that we be able to simulate the amount of fuel that a motor is going to see. So if we were running a snowmobile motor, we'd actually be running a fair amount of pressure here because they do run a fuel pump on a snowmobile and they pressurize the fuel into the carburetors. In most cases, we're running ATV motors or dirt bike motors, which are gravity fed. So this adjustment screw right here allows us to change the fuel pressure to simulate a gravity feed system. Once it goes through after the regulator, it drops down, it goes through the fuel pump and into the tank. So that's actually backwards from the way it works. It picks it up at the tank, runs up through this flex line, goes through the fuel pump. That generates about 8 or 9 psi. That 8 or 9 psi feeds into the pressure regulator. We drop that down into anywhere between half a psi and about 5 psi for a snowmobile. That runs up, and then the line will hook into a carburetor. So we have a battery on here that runs our, see if we can back off a little bit. That battery runs any of our 12 volt items. Obviously you can see there's a starter solenoid, the trusty old Ford starter solenoid that allows us to trigger the starter. So that battery cranks our starter. That runs our 12 volt fuel pump. You'll hear all that kind of stuff come on later on when we turn things on. So that battery is underneath there, and it's enclosed in a case so the vibration won't bother it. And you can see we use some pretty hefty battery terminals so we don't have any loss of power when we're cranking. Then we have a fuel cell. We originally thought about putting the fuel cell externally. That way we could pull it out of a gas can or something like that. But I really wanted something that was all in one and I didn't have to mess with it too much. So this is a fuel cell for a race car that's available from Summit Racing. It's a real nice fuel cell. It is full of foam. It has, I don't know how well you can see it, it has a rollover valve there which allows the tank to ventilate. But if you shake it around too much, it closes and doesn't allow any fuel to slosh out. And then right over the top here, we have the fuel pickup or the fuel fill. So all you have to do is flip this up, rotate the cap. Inside there, you'll see the fuel and all the fuel foam. We write down what we run for fuel each time, what we're running in terms of the type of fuel, the octane of the fuel, and if it's a two-stroke, you can see that it's mixed. How each motor that we put on here for an ATV or a dirt bike will have a mounting attachment, an adapter, I guess you could call it. And you'll see that when we go ahead and put this Ducati 4 motor on here in a little bit. For snowmobiles mount on a flat plate anyway. So in those cases, they actually drop down through the plate and just bolt right on. That is our little dynamometer. We'll get into the electronics and the software later on. One of the other features that I did add pretty quickly was this power panel. This power panel is set up with a protection for electrical surges and things like that, because I do have computers and electronics plugged into that. It also has a couple of spots that are spread out a little bit that are specifically set up to run adapters, because we do have a 12 volt small amperage charger that we use to make sure we keep the battery fully topped off. We also have a 12 volt power supply for the dynamometer brain. So that's the dynamometer. I'll go ahead and put this camera back in the stand, and then we'll go ahead and put a motor in. All right. This is our Kawasaki Ducati 4 ATV stand. It also does the Ducati 3 three-wheelers by changing the front bracket assembly. We try and keep them as modular as possible because they take quite a while to build properly, get them all lined up. So we're going to start out by prepping the adapter piece. Need to pull off the mounting hardware so that we can set the motor in and get it all lined up. All of the adapters utilize the factory motor mount locations, and that's intentional because we want to be able to simulate all the activity in as close to the as-run condition that we can. All right, now that we have this all apart, we're going to go get an engine, and we're going to set an engine in the stand. Okay, here's our 352cc big bore Ducati 4 motor. This is a Ducati 4 with a stock stroke and an 81 millimeter bore to take it from 248 up to 352 cc's. It has a mild port job, a large reed cage. You can see it has a reed spacer in it. Has a 5 millimeter longer rod to improve the loading of the crankshaft and the angularity in the cylinder. It has pretty mild compression. We're going to go through after we get it lined up on the dyno and do a compression check. We'll do it before we fire it up. We'll also do it after we have a few minutes on the motor to see how things are doing. It's really was built to be a torque monster. This motor's recently been sold. It's going to go find a new home along with all the other Takatis in Joel Little's garage. So I think he's anxiously awaiting this big motor to see how it works out. We've run it in a couple of our own quads. Ran it in my own quad a couple of years ago. My son ran it. It's pretty respectable. It's definitely a torque monster. It's not a drag bike, but right off the bottom, it pulls really well. So we're going to set it up with electron carburetor. We're going to use a KX250 ignition in it off of the two-wheeler. And since it is a really torquey motor, we're going to play with a couple of pipes while we have it on the dyno. We're going to start out with a Bill's pipe, which is a really, really torquey pipe. We'll do a DG pipe, which was another really good torquey pipe. Has a bit more volume than the Bill's pipe does, which I think this motor is going to like. Maybe we'll try a Power Pros. Dynoed this motor in the past with the FMF, the Power Pros, and the ILR Pro pipe. This motor is a bit big for all of those. I haven't had a chance to run this with a Bills or with the ILR Pro 3, which is our big bore pipe. So this would be a good opportunity to try and do a few of those and see what this motor likes the best. So you can see it doesn't have an ignition in it right now. Joel went ahead and sent me the KX ignition for this, as well as the flat slide electron carburetor. So I'm going to go ahead and get the ignition in, get the coupler on, and I'll come back to you when I have those bolted on, and we'll get this thing in the dyno lined up, and we'll do some checks on it. You can see that we have the ignition on. It's quite a bit smaller diameter ignition than the factory Takati 4 ignition. This is a KX250 ignition. We're going to run the complete ignition, the backing plate, the smaller flywheel. We have to go to the KX CDI box, and we're going to run a better coil on this one because the KX coils were kind of notorious back then for being weak. The KX ignition does not just bolt right into the Takati 4. It does require some machining. The backing plate has to be machined. It has to be clearance. It has to be re-indexed, new marks put on it. And then in order to run it on the dyno, we have to do a modification. You can see that there's 3 Allen screws that hold the coupler driver onto the flywheel. So we remove 3 rivets. We drill and tap the 3 rivet holes, and they become bolt holes. And then when we're done with all the work on the dyno, we'll go ahead and put 3 grade 12 Allen screws back in those holes to tie everything back together. So it can be dynoed again, or if it never needs to be dynoed again, at least those have been replaced. So what we're going to do now is we're going to slide it in and lock the coupler in and go ahead and put the bolts on to hold the base plate down. Then we'll do a quick check to make sure we're properly aligned. Once we get that done, we're going to hook up the carburetor, the fuel, the rest of the ignition, and then we'll do a couple of quick checks on the motor. Okay, there you go. It's that simple. I'm going to go ahead and snug up those bolts and get the rest of the equipment out, the carburetor cables, all that kind of stuff, so we can get it ready to turn over, do our compression check, squish, things like that. So this is what it looks like when everything's hooked up. The exhaust is on, ignition's on, everything's aligned, the water lines are all hooked up, and it's just about ready to fire up. So we're going to go ahead and end this video. If you want to see this motor run, there's 2 more videos after this. Kind of a spoiler alert, the next video after this one, we run it and we break it. And then the video after that, we fix it and we make some very, very impressive horsepower out of this little tiny motor. So if you like the video, please subscribe to the channel and you'll get notification each time the new videos come out. We'll do a bunch of other motors as well as some upgrades to the dyno as we go along. And here at ILR Performance, we do a lot of performance work. So we're going to do some boring videos, some honing videos, some crank rebuilding videos. So go ahead and click that subscribe and you'll get notified right away. Thanks for watching.